Hello everyone. In this video, I'm going to take some code that one of the Discord users shared of their Tic-Tac-Toe challenge, and I'm going to do a bit of work on it to explore some ideas that I've seen a lot of people struggle with. This code comes from Jay Fishfillet in Discord, who's been kind enough to let me use their code as a starting point here. The topic I want to spend some time on is static versus not static classes and a bit of object-oriented design. This object-oriented design thing, a lot of people really struggle with it. It is a hard thing. So if you're struggling with it, don't feel bad. The sad part is the C# Player's Guide as a book can't do justice to object oriented design. Like that really deserves its own book, or a whole series of books. And it also requires just time. It requires practice and experience and just trying out all the different options that are available and getting a better feel for this really did work better in this situation versus that situation. So it does take time. Don't feel bad if you are struggling with it or if it is taking time. That is totally normal. But I am excited to be able to spend some time here and kind of work through this in a situation where I can provide some sort of supplemental stuff beyond what the book has to kind of just talk through design for a little bit. So I'm excited to do that. I think this will be fun. And like I said, let's just jump into the code here and see what we've got. Now like I said, I do want to focus on specifically just this topic at hand, the static versus not static classes and this object-oriented design. I don't want to get into the weeds on any other details here. We'll just keep it narrowly focused on static versus not static classes. So what we've got here, this code has 4 classes. There's the Tic-Tac-Toe class, and this is sort of the main class whose responsibility is run the game and manage the game. So it's got references to the players, and it's got this run method and so on. There's a player class that represents a single player. It allows the player, it does the interaction with the console window to get the players' choices. It knows what symbol that character is, an X or an O. And then we have this board class that represents the state of the board, and it represents it as an array, which I think is a very reasonable choice. And then there is this endgame class that's responsible for deciding if one player or another has won or if it's a draw. The notable thing here, the thing I want to kind of focus on is that these 2 classes are static classes and they're not. Now, I don't know all of the reasons why it's this way, but I suspect that a lot of what this came down to is putting the static on here is that these were things that needed to be used kind of in a lot of different places. And it was a question of how do I ensure that people can access things like the state of the board from a variety of different places, because if you look at some of this stuff, the things that are related to the board, they get used in player, they get used up here in Tic-Tac-Toe, and in fact, I think, they get used down here in Endgame. So they're kind of used all over the place, and to just make them static makes it easy for things from anywhere to be able to reach in and do something with it. And in fact, let me go a step farther here and pull up the book. There's a section here in level 23 about object-oriented design that talks about how do you get objects to collaborate. And there's a bunch of options here, and static members is one of them. This is an option, a possibility for doing this. So that's the path that this code is currently taking. And mostly what I want to do is I want us to explore some of these other options, and I actually think by the time we get done, we will explore this method parameters one, this constructor parameters one, and this creating a new object one. Now, having said that, let's jump back over here to the code. And like I said, we'll look at these static classes. So let's start here with this board class. Now, so we're using static for this. There's static position, and the static is position taken, which is a parallel array that's just keeping track of whether there's something in there or not. And the thing about static is this: the way I describe it in the book is that it's shared. So there's one character array for all instances of the board class, or one bool array that is position taken. So there's one of these for the whole world. Like by making this static, then essentially what we're saying is this is like the universal board. There is one board and one board only, and it's like this shared, the universal board. And in this specific case, that could work. In fact, that does work. Like, I think this solution checks off all the boxes, and it does what it's supposed to do. But it is using it demands, by having this be static, that there is basically the universal board that everyone in the whole universe uses, and that's it. And I think it gives us a lot more flexibility in general to say there may not be one universal board. We may, for example, it's pretty easy to imagine, we may want to run multiple games simultaneously. We may want to have, multiple 4 players playing two games or something like that. By making it static, there's no way to reuse this without it being the universal board. So there is the one board for everybody. And I think if we make it not static, it gives us more flexibility, even though, like I said, I think technically this checks the box for the challenge. I think it's a fine solution. So if we want to make this not static, the first thing we got to do is remove the static. So we remove that, which allows us to have non-static members. And now we're going to remove the static from each of these. So now with each of these so now these are, well, let's start with this one. These are the characters that fill up the board for this single instance, this specific board. And a different board instance will get its own character array, its own state. So with this now, we can have 2, 3, 2,000 boards if we wanted. Same here, we got this second array that's got some extra metadata about whether that position is taken or not. And then here we have this instance method that it's based on, for this specific board, do this set board thing, which I'm not 100% sure I'm following all this, but basically this is it definitely displays the board, and then it does some stuff to indicate whether a player won or not. So I think this is mostly about display and showing the current status, and I think this is good code for that. But again, this is directly associated with the board that we happen to live in. It's an instance method, so it will be using the data for this specific board. So with that, this class is prepared now to be used by, to be reused, to be the class that defines any and every board in the world, but there's no longer a need for there to be just one single universal board. We could have 2 or 3 or 2,000 boards if we want. So that's step 1. Everything's good so far, but we do have 32 errors with that one change. So that is fixable. And you can see, I'm going to collapse this class here again. You can see that the endgame class has compiler errors. The player class has compiler errors. And the Tic-Tac-Toe game class has compiler errors. And I think the solution for each of these is perhaps a little different in each case. So let's start with this one, this Tic-Tac-Toe game, because I think this might be the simplest. So we do have one instance of this represents the game as a whole. And we do create one instance of it, and we tell that instance to run. That seems pretty reasonable to me. The catch now is this guy used to be trying to access, the static stuff, this universal board, this global, state, this global, the universe's board. And we want to change that. Instead, what we want here is for the Tic-Tac-Toe game to have its own board. So every Tic-Tac-Toe game we create should just have its own board. So if we make, a second Tic-Tac-Toe game, then it should just have its own its own board. So a second Tic-Tac-Toe game has a second board. A third Tic-Tac-Toe game has a third board. A 2000 Tic-Tac-Toe game has a 2000th board. So the way that I would approach that here would be to just add in. So this is it's gonna have to make a board, and it's gonna need to remember it. So we're gonna have a field here, and we could make this private. I don't think it needs to be public. So we'll just have a field here that stores the board. And I might normally put an underscore in front of this, but given how the capitalization, I'm sticking with the capitalization conventions that are in this file. So I'll just leave it like that. And then we need to initialize that. And we could just say, kind of like what we've done here with the players, we could just say new board and be done with it. But I think what I'm going to do, this is functionally equivalent. It's the same thing. I'm just going to come down here and I'm going to say public. I'm going to make a constructor tic-tac-toe, because we'll need that in a second. And I'll show you why equals new board. All right. So now this class has a reference to a board and in the constructor. So when we create a new tic-tac-toe game, as a part of that, we will create a new board. And jumping back here to our how to collaborate, that is this first option. Well, that is that is this first option here. We just make a new instance with a new keyword. That's all we've done. We just said, new board. So like I said, for every tic-tac-toe game we create, it will create kind of underneath it its own board that it's managing and it owns, and it's got it right here. So every time we make a new tic-tac-toe game, the new board also comes into existence, just kind of coming along for the ride, and away we go. And now in this case, we don't want to access what used to be the universe's board, but rather our board. And yeah, so we just change it to reference, instead of the class name, we'll reference the field name here. And same with all these other ones here. All right, so that should, like, that fixes that part. So now we're saying in this method, as we run, we're going to work with the board instance that we have created, that we own, our own board instance. And that's a good first step. Now that we've only solved, like I said, we still have issues down here in the player class, and we have issues in the endgame class. But we'll deal with those next. Okay, so let's do that. The player class, it needs a board. Again, it was sitting here saying, I'm going to access that universal board, and we've taken that option away. So a player instance somehow needs to know, like, what board am I as a player supposed to be working with? And there's a couple of ways that we could do this, because now there isn't, like I said, there isn't just this universal one. We have to somehow find out. We have to somehow be aware of a board kind of separate from this. Now, I do think that we could use a similar strategy. Like, it makes sense for the player to be like associated with, to know about the board that it is playing on. And so we could do a similar thing here. We could make a board, field. And then down in here, we would just say, we've got the board that we're supposed to be working with, and we'll just interact with it. So that fixed those issues. The catch being this board class, and I think that's what this is telling us, this warning. We never set this up. Now we could just come in here just like we did with the tic-tac-toe class, and we could say board equals new board, right? That's what we did on the other one. So could that work here? Well, the answer is no. And only because the player class is like the two player instances that we create up here. are supposed to be playing on the same board, and that board is supposed to be the same one that this Tic-Tac-Toe instance is managing as well. They need to all be sharing the same board. Otherwise, the X player will play on a board, and then the O player will get their turn, and they'll have their own copy of the board, their own board that, three different instances of the board class is what we'd end up with here if we just did it this way. And we really want them all to share the same instance. So in order to share instances, we're going to have to pass the instance that we made here around to the player class. Now we'll use this next strategy here, constructor parameters. So in the event that a class isn't supposed to, that it doesn't just directly own the thing, it's supposed to be handed it, we will use this constructor parameters option instead. So what we'll do down here is, instead of saying new board, we'll say, well, I can't create the board because that would just be me creating my own. Rather, I'm going to have you pass it in. I'm going to have you pass it in as a constructor parameter, and then I'll just remember it. So, well, now I got all these names are. So this dot board will refer to this. The unqualified not this dot board will be this. And that, by the way, I mentioned that earlier. That is a reason why a lot of people will rename this. I just hit Control R, and then I'm still holding Control and hit R again to rename. So if I call that underscore board, now I don't have that problem. Anyway, so, but again, I'll keep the naming conventions kind of as they are here. So, and that'll be fine, because I can use this dot board to refer to this, whereas this board refers to this. Meanwhile, down in here, there is no parameter or local variable called plain old board, so this will just refer back to that. Anyway, so I think we fixed the player class, except right here, like this when we're making these player instances, we said we need to be given the board, and in this case, we have not made it, so they're handed off the board. Now we're not going to be able to do that in an initializer like we did here. So I'm going to scoot the initialization for player 1 and player 2 down into here. So we'll do player 1 equals new player, pass in the X, and now we pass in the board that we already created. So now this will be the same instance, and we do the same thing for player 2. And now we can remove these initializers. There. Now, the Tic-Tac-Toe game will create a board. There will be one board created, and then he'll just share that with the new player instances that he's creating. So the game itself and the two players all know about the same instance of the board class. But now we could go create a new Tic-Tac-Toe game. We could create 17 Tic-Tac-Toe games, and they'll each make one board and two players, and each of those games, the players within each of those games will know about the correct board within each of those boards. So that solves the complications with the player class, and the only one we have left now is this endgame class. Now there's some options here, and we could do something similar. We could hand off the board to the endgame when we create a new instance of it. But right now, this endgame class is static, so there is no instance of the endgame class. So we're not going to be able to use either of the strategies we just used. We're not going to be able to just create a new board, because this needs to be a specific board. And we also can't just pass it in as a constructor parameter because this class is static. Now, we could make this not static. We might explore that in a second, but first we're going to try it without. All right, so the other option we've got available to us is this method parameters. And this one unlike the other two options that won't work in this specific case, not without making that this endgame class also not static. The idea here is well, we'll just if that method needs to use it, we'll just pass it in as a parameter to the method that we're using. So what we'll do here is we'll say, essentially this endgame becomes this little utility that will tell us whether for a specific board, if a player represented by a character class is if for that board the player has won or not. So what we'll do is we'll say we'll just pass in the board. So this guy doesn't have to reach out to what was once the universal board. It can be told, here is a board, an arbitrary board, and I want you to make a decision on whether that is whether this player has won or not. And now the rest of these, and this is going to fix a lot of these compiler warnings here, is just going to be we'll use this specific board that got handed off to us and make a choice about that instead of going to the universal board. Random side comment. A lot of people I've seen complain about, like, is there a better way to handle this? Like, check. You could turn these into a loop. This could be a loop. This could be a loop. This, so a lot of these, they could be, you could do a loop for some of these, but it's like, this was how I approached the solution as well. Is just, there's only eight choices, and it's pretty easy to just say, like, 0, 1, 2, 3, 4, 5, 6, 7, 8. So I feel like this pattern is more common for a 3x3 board than using loops. Now, if you had to do a 2000 by 2000 tic-tac-toe board, then you definitely want loops. But for the 3x3 board, this is not uncommon to write it out this way. Just kind of like explicitly say, like, here is a scenario. Are all of those the same thing? Here is a different scenario. Are all of those the same thing? And just like hard code, like write out your options. Okay. So we still have a compiler error here. This one's pretty minor, but the idea is this class is actually, its accessibility level is internal. Like, we didn't put a modifier on here, so the default for a class, like up here at the top level, is internal, and this method is public. So that's what this compiler error is saying, is you're trying to, like, this thing isn't supposed to be usable outside of the project, yet you've made this public, and our options here would be to make this internal, which is an option, or to make this public. And I think I'm going to go that route, because in the scheme of, if like, this is meant to convey whether, if somebody were reusing this, if we would expect them to be able to reuse this, or if it's meant to be like implementation details. And if somebody were going to reuse this project, I think we'd expect them to use the board class. So it makes sense on my mind to just make that public instead of reducing this down to internal. But yeah, so now with the board in here, then this did player win is able to just look at the board that's given to it and make a determination on whether, true or false, whether they whether a player, that board represents a player having won or not. And then the other thing we need to do here, so this is draw, probably needs essentially the same thing. Like, we want to pass in a specific board for it to answer that is draw question on, and then we'll just pass. So now we can use the board that we're asking the question about, and then we'll just hand this board instance over to these did player win method calls as well. And yeah, so that fixes that class. Of course, now we've got a couple other errors up here, and that is because we changed this. We changed the signature, and now it requires a board. So let's fix these. So up here in the tic-tac-toe game, this is saying, now we've changed this to, rather than just did the X player on the universal board win or not, instead of that, it's now did the player win for a specific board. So we need to give it our board, the board that this class owns, which is that. So we'll just pass that in, and then same here and same down here in all these places. So now the end game, we can ask questions about specific boards instead of having that, like that concept of like a universal board with the static thing on there. And yeah, so now this one we also need to pass in a board, but what board do we pass in? Well, that's where the this keyword is useful. It's we're in it. If we want a board, it's us. So this, we pass in the reference that we have in any instance method to ourselves. And so we'll just pass in this. There. And now with that, we would be able to come up here and do make a second instance and run that one. And we could run them in parallel at the same time if we want. So, and when we call this, it will go create a new board. It'll create two players that know about the board, and then it'll go run that game. And I think that about does it for the board class. Yeah. Yeah, so we could do a similar thing with this endgame class. Like this is static, and there's one thing that's tracking endgames. I actually think in this sense, like this makes more sense in my mind to be this like static universal thing, because this is really about just checking this. Like it could be there's one like universal entity that has the smarts for determining who won or not, and you could always go back to that central, the universal endgame decider, and make a decision from that. And I think that's a strategy that makes a lot of sense. Even if you had 1,000 boards, you could still have one centralized endgame thing, and that's kind of the situation we've got now. So in this case, I think this could be static, and I think it could be fine. I think this makes more sense for it to work that way. Though this does have state here about a draw, which I'm not sure. Like I think the only place that's used is like right here. And I actually think we could. I think if we delete this and then delete this, like nobody's. Let me double check that. Let's make sure. I don't think anybody is using this. So I'm searching for references of just the getter, because I know the setter's used. We just saw that. So this isn't used. The getter isn't used. I suspect this is vestigial. Like it was meant for something at some point, and now I think this is draw. It has replaced it. So I think we could do that. And now, like I said, this guy has no state of his own. He's just got a couple of methods that he can use to answer questions about a different board. So I do think that this guy makes a lot of sense as just like this universal centralized concept, the centralized entity, kind of like the convert class or the math class or the console class, where there is within the world of the program, there is only one of them. There's a centralized mechanism rather than instances. But let's, I mean, why not? Let's give this a try and just see how we like it. We could have an end, like this end game like manager, this end game concept for every game we create. And so we could remove the statics on here, remove that static, and remove that static. And now let's go up here to the top. And just like we did with the board, we could say we're going to have private end game. The game has an end game instance, and we'll do the same thing here. We'll just say end game equals new end game. So now we create a new instance of this end game, like what we did with the board, and then we just come down here and call our own little end game object, and so now there's going to be for every game that we run, for every Tic-Tac-Toe instance that we create, we'll have our own, like, contained directly inside of our own little thing that manages the determining what the game has ended, our board itself, plus 2 player instances, all just kind of self-contained within this game. And like, that's a good start. We still have at least a couple, I think, warnings. So this spot is a little interesting because this was using endgame as well. So the board, either the board needs to know about the endgame object for the game that it is a part of. And again, like, this is a same concept as before, same issue as before, is somehow we need to know about the correct endgame object. And this guy could just, in his constructor, we could just make, like we did before, we could do public board. And so he could have we'll make it a private field. And he could just create a new, he could just create a new instance here. And in this case there, even though that would end up creating a new endgame in here every time we create a board, that's not, like, that could work. Actually, if we did that, well, I was going to say, if we did that, we don't need the one up here, but this guy was using the endgame as well, wasn't he? Pretty sure, yeah, right there. So he needs it. So it seems like the 2 things should be the same instance. So I think, yes, we created it here. I don't think that's the right way to do it. I don't think we should create a new one. I think we should, if we're going to do it this way, we should pass it in, and just like what we did before, we should just have this guy give us the reference, save it off into a property, or in this case a field, and then we just use it. And then we have to come back up here and link the objects together. Now we pass in game and game. So now we have this little like constellation of objects that we've created here. And Tic-Tac-Toe ends up being kind of the orchestrator of all these little objects. We have this endgame object that is responsible for making those calls about whether something has ended or not. And then we have this board class that represents the current state of the board, and he's also told about, so he knows about the end game, and so he can have the end game do stuff for him. He can delegate to the end game and we just saw that. And then we create 2 players, and each of those players has to know about the board. They don't have to know about the end game. So this little constellation, the game itself owns there's 4 other objects that live inside of the game: the end game object, the board object, and 2 player objects. And these get, like, interlinked as necessary by the board getting the end game, the players getting the board. And yeah, so again, we kind of push the end game into like an instance thing. In this case, it's I think far less justified than the board, because I do think that it makes sense to have like this centralized static, like, universal logic for end game stuff. Like, there wasn't a compelling need to do it differently. But at we are getting to the point of being able to make instances or sorry, some more complexity like inheritance. Like you could in the future, you could imagine having, and I don't know, this isn't tic-tac-toe anymore at this point, but you could have different like things that determine whether somebody won or not. And yeah, so it could yeah. So if we get to a point where we could have different strategies for deciding a win, and in that case, there might be, you might use, and we aren't there yet. We're getting there. You might use inheritance and like polymorphism and some stuff like that to like define different winning strategies or like different end game strategies. And in that case, where there's the potential of different ways to determine a winner, and again, tic-tac-toe doesn't really have this, but imagine, then it gives you that flexibility to say this game's win conditions are defined this way, and a different game's win conditions are defined in a different way. And in that case, you wouldn't want a centralized thing, because that centralized thing can't manage the win conditions for every game. To just have something that has the win conditions as a part of the game makes more sense. So again, in this case, I kind of like going back to the state where we were. Let me undo and get back to it. I kind of like going back to this earlier version where it was just a static endgame class. Like, I think that's an appropriate use of endgame, where there is only one universal way to handle deciding winners and draws. But like I said, there is a scenario where putting that into an instance as well makes sense too. So anyway, I hope that gives a little bit of extra, like, I don't know, thinking or discussion around, when you might create instances and versus static classes. Like I said, now we can create as many tic-tac-toe games as we want. They're all sort of self-contained. They're all independent of the others. And anyway, just some more options for object-oriented design, more things to be thinking about. Like I said at the beginning, this kind of stuff, it takes getting used to. So it's okay if you're like, I really just don't know. There's just so many tools that are available, and it takes a little bit of time to wrap your mind around. But yeah, anyway, that is it. I will stop the video here. So like I said, hopefully we'll do more of this kind of stuff in the future. So thanks for watching.